Today we're going to talk about integer representations and different ways to represent the same number. And so I want you to start by thinking about a number base 10. So if I write the number 3517, what that really means is 7 ones, 1 10, 5 hundreds, and 3 thousands. And so the number 3517 can be written as 3 times 1,000 plus 5 times 100 plus 1 times 10 plus 7 times 1, which is the same as 3 times 10 to the third plus 5 times 10 squared plus 1 times 10 to the 1 plus 7 times 10 to the 0. And we can do this with any base. So in this case, our base is 10 because I'm always raising 10 to a power. And our digits that we're allowed to use are 0 through 9. Those are the numbers in the front here. And so if I want to use a different base, so let B be an integer greater than 1. Then what I can do is I can write any number I want n as something times b to the power, and then smaller power, and keep going until I write a 2 times b squared, a 1 times b to the 1, and a 0 times b to the 0. So I could do that for any base. What we did before was a base 10 example, but I could use any base I wanted to do this. So if you have a different base and you're converting to a decimal number, when we say decimal number, what we really mean is base 10. Then what you do is determine the value of each digit, and it depends on the number system you're in. And then you multiply the column values by the corresponding columns, and then you add them up. So it sounds complicated, but if you look at this, 3752 base 8. So this is the 0 column, the 1 column, the 2 column, and the 3 column. So this is 3 times 8 to the third, plus 7 times 8 squared, plus 5 times 8 to the 1, plus 2 times 8 to the 0. So 3 times 8 cubed, so do 8 cubed, 512, plus 7 times 8 squared, plus 5 times 8, plus 2 times 8 to the 0 is just 1. And then you just add up all these numbers. So 3 times 512 plus 7 times 64, put this in your calculator, plus 5 times 8 plus 2 gives me 2026 base 10 as a decimal number. So how do we go in the other direction? What if we have a decimal number and we want to convert it to a new base? So this is decimal to new base. What we just did was new base to decimal. And this is called the base conversion algorithm. And what it tells you to do is divide the decimal number by the value of the new base using the division algorithm. Get the remainder, and that's going to be your rightmost digit of the new base number. So that's going to be the number that's like times b to the 0. And then take the quotient and divide again, and just keep repeating until your quotient is 0. So this says find the base 9 expansion of 320,965. This is in decimal here. So if we wanted to, we could write this as base 10. So what we're going to do is divide 9 into 320,965. And we can do it the long way. We'll do 1 the long way, and then we'll see how we can make it faster. So I'm just doing long division. And what I get is that my quotient is 35,662 and my remainder is 7. So when I'm writing my base 9 expansion, the 7 is going to go all the way over here on the right. Then I'm going to divide again. So I'm going to put 9 into this quotient. The way you can do this in your calculator is you can do 35662, that was my quotient, divided by 9, gives me 3962. So my integer part up here, my quotient, is 3962. To find the remainder, do 3962 times 9 and then subtract. So 9 times 3962 is 35658. When you subtract these, you're left with 4. So my remainder is 4. So that means 4 is going to be that digit. Then I just keep going. 9 into that quotient, 3962. Gives me 440 as my quotient. 9 times 440. You multiply that and subtract. Gives me remainder of 2, so that's a 2 there. Keep dividing. 9 into 440. Remainder 8. Keep dividing. 9 into 48. Remainder 3. Keep dividing. I have to keep going. 9 into 5. 9 doesn't go into 5. So I put 0 here. My remainder is 5. Once you have this quotient of 0 where 9 doesn't go into your number anymore, then you're done. So the base 9 expansion of the decimal number 320,965 is 538247. You could check your answer by remembering this is the 0, the 1, the 2, the 3, the 4, the 5. So you could do 5 times 9 to the 5th plus 3 times 9 to the 4th plus 8 times 9 to the 3rd plus 2 times 9 squared plus 4 times 9 plus 7. And that should give you the 320,965.